Let's go. So we are here to talk about frontends. So far we have only talked about Motoko, which is the backend side of things. But of course, when we are using applications on the IC, so when we are using, let's say, OpenChat, they have a frontend, so we can access the application. Discover, they have a frontend. All other applications, user-facing applications are going to have a frontend. And also, we have websites on the IC that are simply, they are simply just static websites. So for example, internetcomputer.org is actually deployed on the IC. And it's a website. It's just a simple website. There is not necessarily a backend. There is just, there is just like a website with information and links and pictures and all sorts of things. So how do we deploy a frontend on the internet computer? That's the topic of today. And for that, I will show you a simple example using the dfx SDK. I'll create and deploy a website. So there is a command called dfx new, and essentially it automatically generates a new project for you with a backend and a frontend. So we will use that. We can give it a name. So let's say for today, presentation, websites, let's say websites. And one thing I didn't precise, I forgot, you need to have Node installed on your machine to be able to run dfx new and have the front end generated. If you don't have Node, so let's say I verify, I have Node installed and I recommend to have this version 18 installed. I think it's the latest supported version. I recommend this one. But if you don't have Node, it's essentially only going to generate the backend for you, and you will miss out on the front-end part, which is the parts that we are talking about today. So I'm going to move inside the directory. So it's called websites. And then we can see the files. So we have all those files. We have a package.json, webpack.config, and a README. So I open this. Okay, so this session is not meant to be an introduction to front-end web development. So I'm assuming that you are already familiar with what is package.json. And you are also familiar with what is Webpack. If you are not, you probably can find information about that on YouTube. And also, it's not necessary for the rest of the session. So what we are interested in is the source folder. And so we have this backend and this frontend. So the backend is very similar to what we've seen so far. It's a Motoko backend. So we have an actor, and then we have one query function, which is a greet function. This greet function takes a name and returns a greet. So hello, and then whatever name you've provided. So that's it for the backend. The frontend is a bit more involved, so we have more files. But it's a simple, I would say, vanilla JavaScript frontend. So no framework, it's HTML. We have an HTML page. We have a script. So this script is, where is the script imported? Yeah, we have a script here. So we have this index.js. And we have a simple CSS file for the styling of our website. And then we have a few other files. So we have this icon, so this ICO file for the icon of the website. We have a SVG file, which we are using on the website. So this is like an image. We have a text file, and this is ic.asset is just a configuration file for the asset canister, which I'll explain what is the asset canister. So let's take a look at dfx.json, and you will notice that this is similar to what we've seen. So the backends, website backends, we have the main file, which is located in source, website backend, main.motoko, so this one, type Motoko. So we know this, we're familiar with this. But the front end, we are not familiar with this. It's the first time that we see this. And there are a few more options that we need to discuss about. So the first thing, the first thing that you see is these dependencies. So dependencies is something you can define for canisters. Canisters that have dependencies are always going to be deployed with their dependency. So if I run dfx deploy and then this canister website frontend, this is also automatically going to deploy website backend because it's listed as a dependency. So that's essentially what it means. Frontends means that this is a front-end canister, and we need to specify the entry points. So the entry points of our frontend is, of course, our index.html file. This is what will be served to the user accessing our frontend. And then the source, which is going to specify where are the assets that we want to upload located. And we can see that we have two source folder. The first one is going to be source website frontend assets. So all those assets. And the other one is going to be our dist/website frontend folder. And this one is the build folder. So I can show you. This is when we run our traditional npm build command. Sorry, npm run build. This is building our frontend. So we compile our files and we create a dist folder. And here we have our essentially what's going to be uploaded inside our canister. So the build version. And finally, in dfx.json, we have this type, which we are familiar with. So usually we have used type Motoko, but this time it's type assets. So what is a type asset? It's a special canister called asset canister. And we can actually look at this canister if we look online. There is a special canister called the asset canister. And this canister essentially is what we will use to deploy our frontends. The asset canister is not something special, like it's not a canister that has special properties. It's a canister that you could actually write in Motoko if you wanted to, or in Rust. Actually, I think it's written in Rust, but it could also be done in Motoko. It's just a simple canister that has a few methods that are needed for us to deploy a frontend. So you don't think about the asset canister as a special like canister that has special privilege and can do things that other canister cannot do. It's just a regular canister, but we have given this name of asset canister because it has been standardized. So of course, we are not going to write the code for the asset canister. We are simply using it. Essentially, what this canister is doing is just storing assets, as the name suggests. Asset canister, it's storing assets. And it's used to serve web pages. So we are going to store our HTML file, our JavaScript files, our CSS files, our assets inside the asset canister. And then we will just access this canister through our browser, so through HTTP requests. And the canister will serve the assets. The asset canister can host around 1 GB in static files. So if you have more than that, if you have a very, very large web application, you might need multiple canisters. And essentially, we can see the methods of this canister. So this is in Rust, but it would be the same in Motoko. We can see that we have a query method, which is a HTTP request. So we can access this canister. And the rest is essentially just storing and removing and uploading assets. So you have batch, the concept of batch and the concept of chunk and asset, but essentially it's just storing file. So let's try it out. Let's take a look at how it's done and how we can use it. I'm starting a replica, so local development before deploying on the IC. I'll deploy on the IC later, but right now I just want to do something locally. So I have my replica, and then I will deploy my frontend. So this canister websites underscore frontend. As you can see, it's saying that it's deploying the frontend, but it's also deploying the backend because we have this dependency listed here. Building frontend, so it's building my frontend code. Creating this dist folder, which we have already because we have already run our build command, but it's doing it again. And now comes the interesting part. So you can see that we are uploading assets to our asset canister, and it's starting a batch, and then it's batching all our assets. So it's uploading our JavaScript file. We have the size of this file, and each file is going to have a specific hash. So we can actually quickly know in further upgrades if we have already uploaded this file or not. So if we don't change our index.js file in the next upgrade, it's just going to take a look at our file, taking a look at the hash that is on the canister, and if it's the same, we don't need to re-upload the file again. Of course, CSS file is also uploaded, HTML file, and all the assets that we have listed. So our logo, simple assets, and the favicon. You can also see that we have zip versions that are uploaded. So essentially it's compressing our files so that it takes less space, and also it's faster to access them when we access the canister. Now we have two URLs. So usually we have always seen this one, so the Candid interface. But now we also are able to access the frontend canister directly. So we can take a look. This is our frontend canister. So you can see we have a web page that is served to us. We have the logo of the IC and this button and this input section. So we will try that. And of course, we have the Candid interface for the backend. So this is our grids backends. We can try it. One thing that is not listed here is the front-end canister via the Candid interface. So I want to show you because I think it's interesting. If we take a look at this canister, but from the Candid UI, so we replace it here, we will access our asset canister from the Candid UI. So this is the same canister here, but here we are directly accessing it. So we are using HTTP request, and so it's serving assets to us. Here we are accessing via the Candid UI. So we can see the list of methods for the asset canister, and it corresponds to what I've talked about previously. So we have the HTTP request here, and we have this concept of assets. So we can delete assets, we can create assets, and etc. And of course, if I try to do something from here, you will notice that I'm probably not authorized to do it because, well, actually, I think I am because I deployed this canister with the, I think I deployed it with the anonymous identity. So this is a special case where anyone will be able to upload assets in my canister, so in my asset canister. So it's not so great, but yeah. Okay. So now notice that we can also interact from the front end with the backend canister. So if I do, if I enter my name here, it's returning this hello Seb, which is the same that we had here from the backend, but on the front end. So how is this done? Let me show you. We have this declaration folder, which has been generated for us when we run the dfx deploy command originally. And in this declaration folder, we have files for the backends and we have files for the frontends. For the backends, I will show you some of the most important files. Actually, let's go through all of them. So the first one is the .did file, which is a Candid file. So .did represents Candid. So Candid, as I've said previously multiple times, it's an interface description language. So it's a language for describing the interface of your canister. So it's simply defining our canister as a service, and this service has one method that you can call, which is the greet method. This greet method takes an argument of type text and returns a text, and it's a query method. So it corresponds to, of course, what we have here. This is a query method. It takes a text and it returns a text. Notice that Candid and Motoko are very close. They are very related to one another because Motoko and Candid were created around the same time and by the same team. So there are a lot of similarities. But Candid is not Motoko, and this type text is not the same as this type text. So when you see a type text with a capital letter, this represents the text type in Motoko, and with a smaller case letter, it's Candid. And it's actually the same for many, many types in Motoko. For example, nat in Motoko corresponds to nat in Candid. Ints correspond to ints. I think bool corresponds to bool, and so on. Okay, so this is the first file that is generated for us. It's the Candid interface. And remember when we were going to the dashboard, we had this concept of, so let me find a canister. Let me find a canister. Let's take a look at the ICP ledger maybe. So ICP ledger, I don't remember the canister ID, but I can find it easily. So I'm looking into my notes. The ledger canister ID is this one. So this is the canister ID for the ICP ledger. And I've talked about that when we were talking about intercanister call. At the end, we have this Candid interface. So essentially, this is what we have here. So this file is the same as the one we have here. Each Motoko canister always has a Candid file generated automatically when you deploy. For other languages like Rust, for example, you need to manually, you have scripts or you need to manually generate this file. But essentially, every canister, almost every canister should have this file available, which represents the interface and the types of this canister in Candid. Now we have a JavaScript representation of this file. So website backend.did.js. This is a very important file, even if it's, I would say, a bit hard to read because it's exporting the ideal factory. Ideal factory is an object that we will use in the frontend. So this is a JavaScript file which we can import in the frontend to interact with the backend. So I will show you in a few minutes how we do that, but essentially this one is crucial because you need this file to essentially have a representation of the interface of the backend in the frontend, if that makes sense. So the next file I want to talk about is this did.d.js. If you're familiar with TypeScript, it's a declaration file. So it's a type where you have types. Essentially, this is necessary if you're using TypeScript and you want to have a type for your canister. So for your actor in the frontend, you want to import the types and use the type in TypeScript. You can use this file. So as you can see, it's exporting an interface service, which corresponds to my canister. And this is the type of the method greet. So it's an actor method, string and string. So optional string here, and then returning string here. And we are also importing the type principal from a definitive package. So definitive principal and the type actor method. So this is like how we can import types in the frontend if we are using TypeScript. Finally, we have this index.js file, which is a key file as well. So this one is slightly more complex because there are a few more things going on. And I'll probably come back to this file a few times. But essentially, we are importing some object from what's called Definity agent. It's a Definity package. We are importing actor and HTTP agents. So actor is how we represent the canisters in the frontend. So it's a JavaScript object. An actor base class, an actor is an object containing only functions that will return a promise. These functions are derived from the ideal definition. So it's derived from this file. And it's essentially an actor is a canister, but in JavaScript. You can simplify it like this. HTTP agent is an agent that will enable us to communicate with the IC network. And this agent can be anonymous or it can have an identity associated with it. So in the case of an authenticated call or not. Then we have the canister ID, which is a constant. So we are actually using it to get the canister ID of the backends. And we are using the environment variables here. If you don't get all of this in this file, don't worry about it, okay? I'm just trying to explain for the people that are more familiar with Webpack and JavaScript ecosystem. But if you are not, don't stress about it. You can use that without having to understand every single line. Okay, so then we have one method, which is probably the most important in this whole file, is the method createActor, which essentially you give it two parameters, the canister ID and some options, and it's going to create an actor, so a JavaScript object that you can use in your frontend to communicate with the backend. We have a few options, so the agent options, and then, well, this is not necessary to, yeah, it's just a little check. This is necessary because it's going to check if we are deploying on the IC or on the local mainnet, on the local replica, because if you are deploying locally, you need to fetch what's called the root key, which is like the public key of your replica to essentially verify the authenticity of all messages coming from the IC. By default, it's not necessary if you are using the ICP network, but if you are using a local replica, you need to fetch the root key. And then it's returning this method, actor.createActor. So you can see we have this ideal factory. This is this file, the agent, the canister ID, and some other options. And it's creating an actor for you. And then we are exporting the backend like this. So from the front-end perspective, in the index.js file, you are simply importing the backend like this. So import website backends, and then simply calling any method that you want like this. So in this line, we are calling the backend. We are doing await website backend.greet, and we are calling this method from our JavaScript file, so from our frontend. The rest is essentially just we are adding an event. So whenever we click on the button, we look at the name inside you remember this, inside this field, and we use the name as a parameter in the greeting. And then when the greeting is returned, we print the greeting here. So that's how we communicate from the front end to the backends. Last file, this one again is just types for TypeScript. So essentially types for this file. So you have type for the actors class, the agent, the canister ID, ideal factory, all of them, they have types in TypeScript if you're using TypeScript. Okay, so is there any question on the link between the front end and the back end? Well, essentially, you can take a look at this file, understand how it works. You can also do it manually. If you want to create an actor, you can use those packages, Definity agent. or you can just believe what I say and believe that it works, and you just import your object, website backend, and you are able to call it at any time like this. So any methods, well, we only have grids, but if we had more method, we would be able to call more method on the backend object. Yeah, I can try another method. So let's say I create a second method, maybe this time an update function. So public function, let's do a counter. So stable variable counter. Increment the counter, so inc counter. And a query function get counter. And I can remove this one actually. So yeah, well, I'll keep it just for the record. So now we have more methods. So I can do a deploy of the backend. No, it's not called backend. It's called website backend. So website backend. And I can run this command dfx generate backend because as you can see, it's not updating my declaration yet. So if I look at the Candid UI, at the Candid file, I still only have this greet method, which is not showcasing the new methods that I have. So dfx generate is a very useful command because it's going to, oh, sorry, it's not backend again, it's website backend, the name of the canister. dfx generate is going to regenerate the declaration files. So now if I take a look, I have the new methods. So I have the increment counter and the get counter method. And this is also reflected in the JavaScript files and also in those files, of course, because those files are importing the others. And now if I go to my websites, so right now my websites, I will need to make a few modifications. So probably I will remove that. I'll call that increment counter, and I will have maybe a section counter value and a button of type refresh. No, it's not what I want. A button with an ID of refresh counter. And now I need to work at the JavaScript level. So I need to add my events. So actually I need to remove this form. I don't want to have to care about the form. So ID increment counter refresh. Well, increment, I'll just call it increment counter value and refresh. So I need to use document.query selector and I need to select my button increments. So this is my button. I will add a button on the elements. So on the click of the button, what we are going to do is call, yeah, that's exactly what I want to do. I just need interact with our canister calling the inc counter method. Okay, so now when we are calling, when we are clicking on the inc increment button, behind the scenes, the JavaScript code is executing, and so we are actually targeting our backend canister, and we are calling the inc counter method, so this one. And the second thing is going to be, so I can remove that. I don't need that anymore. The second thing is going to be document.querySelector refresh, so the refresh button. And in the case of refresh counter, what we want is to, so same thing, we want to prevent the default target. I don't think I need this. Yeah, I don't need that. I need that like this. So we can, so we can copy that and then interact with our canister, calling the get counter method. So constant count is gonna be awaits backend.get counter. So this one. And now we can console.log, maybe that will help us to move forward. So the counter is, and we have the counts, and now we can update the counter value. So let me think about that. So just, so section, so constant section is gonna be get element by ID counter value, and then we will update the text inside. We don't need that. Well, actually, let me just remove those things because it's not so important. Okay. And I don't know why we have to return that, but whatever. It's just, this would also work. So refresh, then we call the backend, we get the value of the counter, then we update this section and we replace that with the value of the count. And finally, we can return. So let's deploy our frontend. And I have to, okay, let's see if it works. So increment counter, it's called, and then refresh counter should give us the value of the counter, and it doesn't seem to work. Cannot read properties of null, reading add event listener. So what I've done, add event listener, increment. Yeah, it's this one that is causing issue. Okay, so increment counter, maybe I should give like a, and now refresh counter. So we are, okay, we are at 2, yeah, because we have clicked twice last time. So we can try again, increment counter, and then refresh, we are at 3. So that's how you would interact with, so you can either query information or update your canister. Any method can be called like this from the front end. So this is very simple, but of course you could think about having like a user database and querying your users, or like all sorts of possibilities, of course. So now I'm going to deploy this website on the IC. So dfx deploy, and I probably need to use another identity. So yeah, I'm still using the anonymous identity. So network IC. And this is how you would deploy a website on the internet computer. So of course we have a website, but we also have a backend. So it's taking a little bit more time than locally, of course, because this time we are really uploading the assets on the IC. And now we have access to our websites. So you can see that we have a strange, or at least strange, not so common link, like address for our websites. We don't have a domain. We have this canister id.icp0.io. There is a way, of course, to have like a domain associated. So for example, motokobootcamp.com, you can have a domain like this on the IC. You just need to do a few steps, which we will not do today, but it takes around like 20 to 30 minutes, and there is a tutorial on it. So I'll probably link the tutorial if someone needs it. Otherwise, yeah, our website is on the IC and everything seems to work. So this tutorial works for, of course, JavaScript, HTML, CSS, but also any framework like Vue.js, React, Angular, Svelte can be deployed on the IC. There is not that much differences with what we've done today, because everything happens before the build process. So your whole front-end development stack is the same as it is on other platforms, so Web 2 development, normal front-end development. You compile to your build, and then you just update your build inside the asset canister. There are a few limitations. For example, server-side rendering is not available on the IC, at least not at the moment. So I'm speaking right now, we are January 2024. It's not available, but it should be maybe at some point. And I'm sure there are a few other like smaller details that if you really dive into, you will feel the difference with a normal Web 2 stack. But otherwise, I had tons of web applications deployed and everything is running smoothly. So I'm going to jump to the question. We still have 15 minutes for this session. Let's see the Q&A. So how easy is... Okay, I've skipped one question. Is there much up-to-date documentation or resource available for hooking up a React or Next project? Well, what is the most up-to-date? I'm not sure what is the most up-to-date, but there are definitely a few guides. I'm just trying to... Yeah, so as you can see here, we have this building on the ICP documentation. We have this section building front-end canisters, and we have customizing the front end, adding a style sheet, JavaScript. So that's what I've done. I've talked about this one. React, Svelte, Vue. So this one probably you're looking for. All of them are fairly similar, so I'll link that. How easy is it to have an IC front-end on mobile? Well, so if your website is deployed, you can see that this website can actually be accessed from a mobile device because it's from the browser. So any browser, whether it's desktop or mobile, doesn't really matter. It could be accessed. Of course, you need to make sure your website is responsive, but there is nothing specific about the mobile. I think you mentioned earlier in the week that Motoko Bootcamp wasn't hosted on the IC. Why was that again? Yes, that's true. Definitely at some point it will be hosted on the IC, but I had some issues with what's called the service worker. So I can show you the service worker. Yeah, actually, I think it's now deprecated, so I should be able to move back the website on the IC. I've just been lazy on that. Maybe I can show an image. Yeah, the service worker is this. So before, when we were accessing a website hosted on the IC, you could notice for a few seconds or like a few milliseconds, you had this loading screen. Essentially, the IC is able to to certify any assets that is hosted on the IC. So that's why when we have certified assets, the asset canister, you will notice it's called certified asset. Essentially, you use the IC signing capabilities to sign assets. So you have your assets stored on the IC and they have a hash. You sign the hash, you send that to a user, and then the user is able to see the signature, verify that the signature corresponds to the public key of the internet computer. And if you verify that, essentially what you have is a set of assets that are sent to you, and you can be sure that the assets you received are the assets that are uploaded on the IC. So even if there is like a middle man in the middle attack or something wrong with the server, you can be sure that you have the correct content. So it's very, very good for example, I think recently we had this attack from Ledger. So Ledger Frontend hack. Yeah, so it was like during December, the front end of a few dApps were hacked using a Ledger connector library and so on. This wouldn't have been possible if they've used the IC, because whenever you are served assets, those assets have to be certified. So it would have essentially prevented those types of front-end attack, which happens more often than actually what we might think. The front end is a huge point of like a weak point, I would say, in the chain, in the way the users interact with Web3 applications. So this certification is super useful, and it's happening with the service worker. Essentially, the service worker is loaded before the website is loaded, and the service worker contains the code that verifies when you receive an asset or website, is this website certified by the IC or not? The problem that I had with the service worker is that I was using some promotion for the Motoko Bootcamp on TikTok. Yeah, most notably on TikTok. I was doing TikTok videos and influencers partnership. And essentially, when users would click on the Motoko Bootcamp website from the TikTok application, it doesn't use their normal like web browser. It's opening like a tab from the TikTok application, or I think it was also the same on Instagram. And these were not compatible with the service worker. So essentially it was printing a message to my users saying, your browser is not compatible with this website, and you need to install like this version of Chrome or this version of Safari. So of course, if the users were to close the TikTok application, open their normal browser from like their application on the mobile phone, putting the link and so on, they wouldn't have any issue. But I mean, most people wouldn't do that. So that was a major issue for me. Now, I think the service worker has been deprecated, which is both a good and a bad thing, because I was not the only one to have issues with it, which means that we lose some level of security. We can still have it in theory, like if we want to. So for example, if we take a look at at the article so I can give you a read, a link. Oh, sorry, I just realized that all the links I've been sending are not sent to you. Just this one. Sorry, guys. I was sending my messages to host and panelists, unfortunately. So I'm going to send the React also link again. Yeah, essentially, you are still able to use the service worker if you want to, but by default, it's not loaded. So unfortunately, you can read about why they've taken this decision, and it makes a lot of sense on a technical level. And I think the only way moving forward would be to have a device that natively integrates the service worker. So maybe at some point when the IC is very popular, maybe browser would natively integrate like a service worker for every website hosted on ICP. Or maybe we would have like a special ICP browser. So it's, yeah. And we can read about, yeah, it's very, very good article. It's very detailed about all the decision and all the implications of removing the service worker. Could you summarize the advantages of building on IC versus traditional tech again? Yeah, I think the main advantage of the IC is that you can have those software that are both trustless and collaborative and co-owned. So if you use traditional tech stack for building a Web3 applications, I don't see there is like a missing link, which is how do you give ownership of your application or your stack to your community? I don't know. I don't think there is a better way to do it than using the IC. So this is for me the main advantage. Of course, it comes with drawback, like the IC is slower, it's a bit more expensive, you have to learn a new tech stack. But it's so much more worth for me in terms of like if we look long term. I think also the network effect of the IC will be huge for ecosystem projects that are able to leverage it. And yeah, that's for me the main advantage, like having everything on chain. Maybe right now most users don't care, but for a lot of reasons, it's going to be more and more important in the future. So at this point, it's seeming like the actual process front end seems like a seamless integration. Yeah, honestly, front end development on the IC it's just front end development. Like there is no um I would say there is no difference probably from traditional front end experience, or very, very slight difference. I do not understand how is the IC more expensive than using big tech cloud. Can you elaborate, please? Um, well, simply because the IC is a new technology. So, of course, new technologies, Amazon Web Services, they have, like, for example, they have years and years of improving their system, making it more efficient, more cost effective. So the IC is not more cost effective at the moment than Amazon Web Service, for sure. It's not that bad. Like, it's not by like if you compare to other blockchains and other ecosystems, you cannot do what you can do on the IC with the same price. It's just impossible. But of course, it's not as competitive as something centralized. It's, I would say, in the middle. And ultimately, maybe in a few years, it will be cheaper, but you have the cost of the technology, the cost of decentralization also. I think decentralized system, mm, I mean, naturally are going to be more expensive than centralized system. At least in the beginning, maybe at some points we figure out, so we are so good at making decentralized technologies that it's not the case. But right now it's, I mean, you have the cost of decentralization. So I don't really understand why the service worker was required for security. I thought IC was unhackable because of smart contracts. Okay, so first thing, there is nothing in the world that is unhackable. It's not true to say that. Even voice faded. Sorry, guys. Mic changed. Ah, yeah. Okay. Okay, it should be good again. So yeah, I was. Okay, now it's should be good. Sorry about that. My my headphones were on the side and I don't know why they decided to connect to my computer. So there is nothing that is unhackable, like it doesn't exist and it will never exist. Even Bitcoin and Ethereum, they could be hacked. In theory, we don't. It's just that it never happens, but in theory, it's possible. There could always be issues in the implementation, and there could be like new cryptography invented. But yes, the IC is considered a secure environment because of cryptography, because of replication, consensus. You have a lot of technologies that makes it a secure environment, and it's not like there are different levels to security. I think it's very unlikely that the IC get hacked, the IC itself, but I think it's very likely that one application gets hacked. Um, when you build a system, you have to think about security. You think in different layers. So what does it mean to hack an application on IC? Does it mean hacking the protocol itself, hacking the application, hacking the user that interact with the application? There are a lot of different layers, and all of them have different implication in terms of how many people are going to be affected. So, of course, if the IC itself is attacked and hacked for some reason at the protocol level, then all applications on top of it are going to be hacked for sure. It's just like if you hack Ethereum, you are going to have repercussions to all applications and so on. But I think this is very unlikely. The second thing that can happen is that one specific application gets hacked. So like a DeFi application or a game or whatever get hacked. And I think this is going to happen. Like there is absolutely no way that we avoid that. It's just part of the learning process. Every day, every week, there is a new DeFi application on Ethereum that is being hacked. And that's just like, I would say it's even like natural selection because I don't mean that for the users, but I mean that for the applications. This is how things and systems get more secure, especially public systems like smart contracts. They get more and more secure because essentially they are out there, the code is open. So if someone finds a vulnerability, it's going to be exploited. And if you have a contract that is out there for many, many years and stores millions or billions of dollars and it's never hacked, you cannot say that it's unhackable because it's always possible in theory, but it's proven that is survived time and it survived incentives because of course if there are money in a system, there are incentives to hack it. So it works like this, like it's a continuous learning process. And I think on the IC, because it's still a new technology, yesterday we've talked about inter-canister calls, how it's risky sometimes, how you could forget the await, the trap. I'm sure some ICP applications are going to be hacked at some point, but it doesn't mean that the system is bad. It's just naturally part of the process with new technologies. Things break. It's just like when you send a rocket in space. The first time it breaks, second time it breaks. After the third time it doesn't break, and then it's more and more secure. Just like the planes, the aeronautical industry, in the first few decades, we had a lot of crash. Now it's not like we don't have crash anymore. We still have some of them sometimes, but it's very, very rare. Um, and then there is also the user side. Maybe the application itself is safe, but the way the user interact with the application, this can be hacked. Like someone could hack my computer and hack, like, I don't know, replace my browser with a malicious version and redirect me to a malicious application without the application itself being hacked. It would be more at the at the user level that it would be a problem. The service worker solve this user problem. It doesn't prevent every hack to happen, but it's a very good verification on the user side that you are actually interacting with the correct version of the application. So it solves a lot of issues. Of course, it doesn't make it impossible for someone that wants to target you, or like, yeah, there are always like factors of risk. Yes, that's what I was thinking, but didn't find the correct terms. Yeah, with the service worker, you can get rid of middleware attack, which is right now a lot of hacks are happening in the middle. Like it's becoming very hard to hack some applications on the blockchain side because it's getting very, very secure, but it's very easy to manipulate users and, I would say, make attack in the middle, how they interact. And that's essentially exactly what happened during this hack. It happened in the middle, so in the communication. With the service worker, you don't make it impossible, but you reduce the risk by a lot. Okay, so I'm just going to take a few more questions and then finish this session. Is there a way to have a conventional URL for a frontend hosted on IC without it being centralized? Yes. So let me send the link. Oops. It's called custom domain, and you can read. It's a tutorial that explains how to do it. Are you saying the cost of hosting an app on IC is more than the cost of hosting it on centralized cloud? Probably depends on what you are doing. Sometimes it could be cheaper, sometimes it could be more expensive. I would say generally it's going to be a bit more expensive, of course, because it's the cost of decentralization. Like this is why making a transaction with Bitcoin is more expensive than making a transaction with your bank. This is why making a transaction on Ethereum costs a lot. The IC has really, I think, um, made such a huge leap forward that the costs are really, really cheap. They are not, I think, really like an issue at this point. For most users on the IC, you don't see the cost. For most developer, it's reasonable enough that you want to build on the IC. But of course, it's still slightly more expensive than centralized system. This is just the nature of decentralization, at least for now. I believe ultimately a decentralized system could be cheaper than a centralized system when everything else is decentralized. Like I think decentralization is a better solution in the long run, but it's hard to be in the middle between a centralized system and a decentralized system. It's the transition that is complex. All right, guys. So we'll stop it from here. Our next session is in 2 hours. We are building the voting system for the DAO. So good luck. Try to build it beforehand if you have enough time. Try to look at project number 4. Otherwise, we'll do it together, and I see you in 2 hours. Goodbye.